little class. I just wanted to clarify some things with regard to null hypothesis significance testing, which is kind of the classical approach to testing hypotheses about relationships between variables or differences between means that we're going to be using for the most part in this class. Now, many of you had some difficulty with this on the last lab, so I just want to kind of make this take a pretty straightforward, simple approach to this. Any statistical test that we might do in this class will result, inferential statistical testing will result in a test statistic value that's part of a test statistic distribution. So let's say we have a t-distribution, we get an observed t-value. That observed t-value is going to conform to a p-value, which basically means the proportion of the area under the curve to the right. Now if it's a two-tailed value, it's going to be the proportion of the area over the curve of the actual observed t-value, and then also the negative version of that t-value, but we don't have to worry about that for now. Basically, that's the probability of getting that result if the null hypothesis is true. That's your p-value. Now your alpha is basically the maximum level you're willing to allow your p-value to be, the maximum level of type 1 error you're willing to allow before the study. So let's say you have alpha 0.05 tail, that's going to be either the leftmost or the rightmost 5%. So that's your alpha. Now generally speaking, if your alpha, let's say if it's a two-tailed test, if a two-tailed test and alpha is actually, let's put it the other way around. If your p-value is less than alpha, then reject the null. When I say reject the null, I basically mean say that you have a statistically significant relationship or difference between the means, and state the specific nature of that relationship or difference between the means. So if it's a two-tailed test, it's pretty straightforward. You want to say, see, is the p-value less than the alpha? That means our observed probability of a type 1 error is lower than the maximum probability of a type 1 error we were willing to allow, so we're okay, we're under that threshold, we reject the null, we say there's a statistically significant difference, and we state the nature of that difference. So don't forget to go back to the means or go back to the correlation or whatever you're doing, whatever the specific test is, go back and interpret which mean is higher than the other. So that is pretty straightforward for a two-tailed test. For a one-tailed test, it's a little bit more complicated. One-tailed test, first verify that the difference is in the expected direction, predicted direction. Remember, with the one-tailed test, if the difference isn't in the predicted direction, then we can't reject the null. We can't say there's a statistically significant difference. And then, if your p-value is less than alpha, then reject. And by reject the null, I mean you say that there's a difference or relationship, and you state the nature of that difference or relationship. In any case, if your p-value is greater than alpha, you cannot reject the null. You would basically say, we don't have enough evidence to say that there's a difference or relationship, or perhaps to put it more succinctly, you could just say there was not a statistically significant difference, or there was not a statistically significant relationship, right? The means might be different, but they weren't different enough for us to be able to reject the null hypothesis. So if the p-value is greater than alpha, always reject the null. Now in reality, decisions are a bit more complicated than this. We need to take into account effect size. We need to take into account confidence intervals. We need to take into account how much statistical power the test had. But I'm trying to keep this part of it, the decision, the dichotomous decision that we're trying to make, which might not be the best idea in the world to have to say, yes, this effect exists, or no, it does not, but that's what we're kind of doing for now. Alright, so from SPSS output, which I think I have pasted here, the p-value is actually labeled SIG. Okay, so in this test, whatever was being compared here, the p-value is 0.13 roughly. So that means we would find whatever difference was found between, I guess this is a one sample t-test, so between the population mean and the sample mean, we would find that about 13% of the time if there really is no difference at all, or if the null hypothesis is true. So it's not unusual enough for us to reject the null, so we would say there is not a statistically significant difference. Right, you'll notice SPSS almost always gives two-tailed p-values. So if you want to turn a two-tailed p-value into a one-tailed p-value, so to go from two-tailed p-value to one-tailed, you simply take p-value, which is labeled SIG, and divide it by 2. Easy as that, right? Now, if you want to go from a one-tailed for some reason, let's say you did it by hand and you just looked up the one-tailed p-value, the proportion to the right. If you want to go from a one-tailed p-value to a two-tailed p-value, then you just simply take p and multiply it by 2. Right? Alright, so hopefully that has served to clarify some of the issues we were having, because it seems like many of you were able to correctly input the data into SPSS, tell SPSS to compute the correct test statistic value, but where most of the issues popped up in the last lab were where many people weren't able to interpret the results. So I'm trying to the extent possible and is reasonable, simplify the interpretation of the p-values relative to alpha. And it's actually pretty straightforward. I mean, it's granted, it's not the most straightforward and logical process in the world. Ideally, we'd want to know, well, what's the probability that there really is a difference? But we don't have that in most cases. Instead, what we usually have is, what's the probability of our results if there really is not a difference, right? So that can get very confusing. You don't have to be thinking about that all the time when you're doing these sorts of tests. You can kind of take a shortcut and just think, okay, two-tailed test, is my p-value below my alpha? If it is, I'm going to reject. If I reject, I'm going to state there was a statistically significant difference, and I'm going to say where that difference was and what the nature of the difference is. So don't forget to look at the means to be able to say, okay, this mean was higher than the other, or if it's significant, say that one was higher than the other. If it's non-significant, then you can just say there was not a statistically significant difference. Okay, hopefully that clarifies things a bit. See you later. Take care.